So in this video, we'll be performing YOLO keyboard key detection. Uh, will so what are the features for this? We'll train the YOLO models for the keyboard key detection. We can run real-time inference using the webcam streams. Easy integration with RoboFlow datasets. Okay, so this is the folder structure. This is the dataset structure setup and okay, so let me take you to the dataset. So I have used RoboFlow for labeling my dataset. Like you can see this image. This is the label dataset. So it will. This is my keyboard actually. So these are the labels which I have created for it, and there are total 100 images. There are total 100 images for this I have used. Although while training this dataset, these images will be extended as we are using data augmentation technique to augment some of these images to increase the dataset to get the better performance. Currently, the MAP score for this is 91.4 percentile percent 91.4 percentage, which is quite a good score. And I have trained this on my own GPU. So let me take to the folder. So first of all, let's source the environment. Okay, first let me move to the directory. See, okay, now source the environment. So okay, so this is the script. You can verify the installation of your system. Like I have used CUDA for NVIDIA RTX 4060. Uh, so this basically checks for all the necessary installed packages and lists what package dependencies are missing from this. Although you can get those installed from the requirements or txt file which is provided here. Okay, so this is for testing the installation. Now we'll come on to this file. This is the main file which trains our YOLO model. We are using YOLO version 8 for this. So this basically trains the model to detect the keys. So these are some of the modules which I am using. So this is basically for getting the optimal batch size. Like in GPUs, if my GPU memory is greater than 7, so it will return 20, it will return 16, and based on this processing, I am using the best optimal batch size available. Train keyboard detector. So this is basically the main script which works, loads the model data, like how many epochs I am using for training. Like I've used it for 150 epochs. What's the image size at 640 pixels? Name. Uh, this is basically used to randomize, randomize the things like no file is saved with the same name. Uh, these are some of the optimization parameters. AdamW is also one of the best optimizer. Data augmentation we are doing. Also memory optimization, and all these things can be seen from the YOLO documentation. What are the different parameters available there? You can get them there. Training completed. The model saved is. I'll show you the model uh, results. So like I trained it uh, every time by tuning these parameters. So here are 5 training files. So the best one is I have saved in the test inference file. So this is basically the test inference file. So I'll be using droidcam to show the results. So it will first basically find all the available cameras. You can also test the single image real-time inference model path. Yeah, this is the real-time inference. You can set the confidence threshold here. Uh, I have tuned it to 0.5. It works fine for 0.5, and it's giving pretty quite accuracy score, which is 91.4. So let's start this. So let me check what was the command part to train model, like webcam. Okay, so we'll be launching this. So let's go to my repo, verify installation inference. Friends, list cameras, part to the best. Okay, okay, okay. I forgot the best model out of this. Uh, Wait a minute. Just give me a minute to check for the best. However, yeah, the things will work fine. The one with the very late. Uh, yeah, I think this works fine. So weights may. This is the file. Let's run this. So first, let me connect Droid Cam to my mobile. Yeah, so I'm pausing it to set up that. Yeah, so I have set up the Droid Cam client. So let's test it real time. So let's test it in real time. Is it recording? Yes. Hmm. So let's get to the terminal. Type the command which I have shown you there in this. Like, first of all, you can check to list your cameras. You can list like using this command, like which camera port you are on. So this is the path. This is the model path. Webcam minus minus camera 2. I'm on camera 2. Yeah, let's run this command. Oh, what happened? Minus minus model. I did something messed up with the commands, I guess. Mhm. Oh, I forgot the model. Copy path. And let's paste it as it is. This minus camera 2. Let's launch this. Now you can see my keyboard, like it has detected all the keys. Also, it is listing on the, can detect from angles also like this. Now getting it at this angle. I have prepared the dataset for various angles also. Yeah. So this is about this. Now in the second PS we need to detect with the finger detection also. So for that, let's change this to YOLO keyboard second. Open this, test inference. Like the accuracy score for this model is a little slightly lower, like it's 90%, but for the individual, like finger detection, it detects 70% fingers and 40% pens, 40% pens, because of the shortage of the dataset. I have not created much larger dataset for this also, like I have used 100 images only for its data set. And to perform for YOLO to perform better, like each class should have at least 100 images for it. Each class should have 100 times should occur like that. So the finger is occurring in 160 and 40 for the pens. That's why the ratio comes 60 to 40. So let me go to the repo repositories. Low keyboard key detection second. Here it says, so here are the scripts. So testinference.py, this is the script which I'll be using. So let's launch it. Yellow keyboard key detection second. I need to move back. Let's quit this terminal. cd dot here cd yellow key 1 second. So urc source YOLO keyboard activate. Okay, so we are in the environment file. So now here also, so this is the test file using the same logic, sorry, training file, and the main logic works here, keyboard key press detector. So what logic I am using, I have created my model, my labels as I'm showing you like this. Like I have a bigger box for the key and the smaller box for the finger tip, and I'm using logic like if the finger box is inside this or is nearby this, using intersection methods and some logic, like if it's near this or it's inside this, it's overlapping this, so it detects the finger and the press. To make it further improve, we can use media pipe for depth processing also, but uh, that will be a quite different task. So this is the logic for the keyboard detection, like we are detecting overlap area, and we are also calculating IOU with better handling. Intersection calculates intersection basically. And now let's detect the key press it's detecting, it will also list the key press. So let's run this. So let me the commands for the launch. Python 3 launch this. Should I pass camera also? I'm not sure. Oh yeah. So oh, you can see all these keys which is detected by it are my fingers. Oh sorry, are the key classes. So let me, if I move here, so it detects the finger pressed S, like it detects the finger pressed this Q3, let's just detect this finger pressed W, this it's pressed 1, it's pressed 2, like by this it's detecting. Oh, I pressed Q, so it quit. So this is how you can see this. This is all about the project. So this is how it detects the which fingers are pressed. Like these are the key presses, key labels. These are the pressed fingers and things. You can get all these to my on my GitHub repo. So this is all about the PS. Also, I'm going to add the readme.md file for it sooner. Yeah, thank you.